Okay, welcome to chapter 7. This chapter is going to talk about absolute value and reciprocal functions. These are two functions that turn up quite often in both pure and applied mathematics. And the first section is just going to get you used to something called absolute values. Okay, it's an operation that you can do to any number, and you'll see the uses of it. And basically all it will tell you when you take the absolute value of a number is one application can be, it can tell you the distance between 2 points, okay, on a number line. Distances are always positive, and so absolute values are also always positives. So an application to this, let me give you an example. Suppose you have the following situation, okay. In 1962, in Alberta, a Chinook raised the temperature from negative 19 degrees Celsius to 22 degrees Celsius in 1 hour, which is pretty crazy. The difference, so what's the temperature difference? Okay, if you go 22 minus negative 19, you're going to get a 42 degree temperature difference. Notice how this is a positive number. However, it's a positive number because I did the operation as the final temperature minus the initial temperature. Okay, this was TF. That's the final, and this is TI, which will give you a positive value as long as TF is larger than TI. But if you did the operation the opposite way, okay, this would be a negative 19 in your notes, then you're going to get negative 42. Okay, the difference is negative 42. A bit misleading. Okay, taking the absolute value of this number, which would look like this, with two lines like a barcode, would force it to be positive because we're kind of talking about what's the temperature difference. Okay, what's the distance between both points. So basically all absolute values do is it forces all results to be a positive number. Okay. Now when you're actually doing this, when you're taking the absolute value, it's very simple to realize it's going to be positive. But let me just highlight what you're actually doing. If you take the absolute value of a positive number, okay, like right here, of course it's simply going to be rewritten. Okay, the absolute value of 0 is 0, by the way. But when you take the absolute value of a negative number, like here, negative 5, you're actually taking the negative of that negative number. Okay, that's how you're converting it to be positive. While this might seem trivial, when you define an absolute value as such, you're going to see that when we talk about absolute value equations, you're going to always come back to this. Okay, so why don't you star this? That was a terrible star. But why don't you star this this absolute value definition in your notes? This will always output a positive number. Okay, or positive expression, I should say. So I did the example one in your notes and you have the solutions. Let's do practice 1. Okay, a very trivial practice. Absolute value of 9 is simply 9. It's a positive value. Absolute value of negative 12 is going to be positive 12. However, when you write it, you're citing this. You're taking the negative of the negative to give you 12. Okay. You can apply this to other situations. So for instance, if we were to apply it to this practice 2 here, given a series of different numbers, write the real numbers in order from least to greatest. This doesn't really turn up, okay, in any other application. This is an exercise, right? An exercise in telling the difference between absolute valued numbers and non-absolute valued numbers. Okay, basically all you're going to do is you're going to rewrite each number as it is. Notice how 2 is not within an absolute values sign. However, negative 5.75 is, so this will become positive. This will be rewritten. Negative 13 over 4. I'm going to convert this to a decimal and make it positive. This is 3.25. Negative 0.5 will become positive 0.5. This will simply be rewritten. Negative 1.1 to negative 1.15. And then we have 3 1/3, which is simply 10 over 3. And the decimal of that is 3.3 repeated. and it will be positive because it's in the absolute value sign. So I'm going to rewrite these decimal expansions from least to greatest. So we're going to start with negative 3.3 repeated. I'm just going to cross them out so we can kind of see what we're doing here. Then we're going to have negative 2, then negative 1.15. Then we're going to have 0.5. Okay, and then we have 1.05, and we have 3.25, 3.5, and 5.75. Okay, now we can stop there. You can rewrite these, okay, in this form how it was at the top. If you did that, then the order would be as such. Right, and I'm just going to go through and rewrite them. 1.15, which one was that? I don't see it up here. 1.15. Not sure where that one came from. Pretty sure it's supposed to be a 2. Why did I want to run? Doesn't matter. Doesn't change the answer. A 1.25. That's odd. And then we have negative 0.5 like this. And then we have 1.05. Then we have 3.25, which was negative 13 over 4, absolute value. So you can see I'm just matching these up again. And then we have 3.5, which was an absolute value. And then we have 5.75, which was in absolute value as well. So there you go. There is our rewritten from least to greatest. So let's move on to evaluating some expressions. And then we'll finish off with the word problem. So evaluate the following. Okay, and that basically means we're going to arrive at a single number solution. Here we go. Absolute value of negative 4 for part A minus absolute value of negative 3. Rewriting these, okay, it's be 4 minus 3, basically, which will come up to be 1. Right? And if I was to rewrite this formally, this is really the operation. However, this can get a bit ugly, okay, as you'll see. I put the brackets, the square brackets here, because I don't want the two negative signs next to each other. So this will be 4 minus 3, right? It'll be 1. I'm going to omit doing this step right here, okay? I think it's a bit easier. For part B, negative 12 plus 8 is negative 4. However, we're in the absolute values, so this will come out to be 4. For C, we have absolute value of 12 times negative 3, which is negative 36 plus 25. That's what 5 squared is. So when we do this, we're going to have negative 11 all in the absolute value. This will come out to be a positive number. All these answers must be positive, particularly for B and C, because the whole expression is within an absolute value operation. Okay, so now let's move on to the last question, which is, on stock markets, individual stock and bond values fluctuate a great deal, especially when the markets are volatile. A particular stock on the Toronto Stock Exchange opened the month at $13.55 per share, dropped to $12.70, increased to $14.05, and closed the month at $13.85. Determine the total change in the value of the stock for the month. This stock shows how active the stock was that month. Okay, so we're given a few values. Let me just highlight what happens. We go 13.55, then we go to 12.75, sorry, 70, then we go to 14.05, then we go to 13.85. determine the total change in the value of the stock for the month. So basically, it wants to know the difference between each one, and it wants to know the absolute value of all those differences added together. Okay, so i.e., so in other words, we have the following. If you want to calculate the difference, I'm going to do this in a different color. Between these two numbers, you would typically take the final one minus the initial one. Okay. If you want to know the type of difference, right? That's a negative difference. However, we want to know the value, okay, the total change in this value for the stock. Okay, so if we take the absolute value, we'll get that particular distance between those 2 points. If we do the next 2 points right here, we would have 14.05, okay, minus 12.70. That'll give you the difference between those two numbers. It would be positive, so this absolute value operation actually will not change the answer. However, we will write them to stay consistent. Same with in the last one. Okay, evaluating this expression will give you the answer. Okay, so let me just recap how I got this. And basically, here are the four numbers, sorry. 1, 2, 3, 4. And it wants to know, starting from this at the start of the month and here at the end of the month, okay, how much fluctuation in total was there in the stock. That number will actually indicate how volatile the stock is. Okay, so it's a useful number to know. Okay, and it will be a positive number. It has to be a positive number. Okay, and because it's asking for the change, okay, the total change of this value for the stock. Okay, so let's do these calculations. Okay, 12.7 minus 13.55 comes out to be negative 0.85. Okay, the next one is going to come out to be 1.35, and the last one comes out to be negative 0.20, all in absolute values. So we have positive 0.85, okay, plus 1.35 plus 0.20, and this comes out to be 0.85 plus 1.35 plus 0.2, and that comes out to be 2.4. Okay, and that's 40 cents, and that's in dollars. So this stock fluctuated by $2.40 in total. So hopefully that makes sense. Work on the practice problems for this section. It's a short section, and then once you're ready, move on to section 7.2.